All right, I'm going to work through the odd problems for Physics Practice 1.1a, which starts off with problem number 1. What are the units of velocity in the SI system? In order to solve this, we look at this table that we have, starting at the top, and we're looking for the quantity velocity, moving down until we find it. When we find velocity, the SI unit symbol is meters per second. Meters times seconds to the -1 power. So for number 1, we would say that the units of velocity are meters per second in the SI system. Next, moving on to number 3. 3 says, write the following SI unit expressions in IB format. That is to say that in IB format we do not have units in the denominator, rather we multiply by units with a negative exponent. 3 says, how would we write kilograms per meter cubed? That is to say, kilograms divided by meters cubed in the SI system. Well, IB is not okay with having meters cubed in the denominator, and they want you to move that out of the denominator by saying that kilograms over meters cubed is the same as kilograms times meters negative cubed. You see, I can move this unit out of the denominator by making the exponent negative. Number 5 says kilograms over meters times seconds squared. I could rewrite this. This meters really has an exponent of +1 in the denominator. So I can rewrite this as kilograms meters to the +1 seconds to the +2. And if I want to move both the meters and the seconds squared out of the denominator, I just multiply and make those exponents negative. So kilograms times meters, instead of +1, now it's -1 to move it out of the denominator, times seconds, instead of +2, it's -2. For number 5, they also ask you to find out what quantity is being expressed, and in order to do that, we have to go back to our table and look up kilograms meters to the -1 seconds to the -2. So if we look at the fundamental SI units and look for kilograms meters to the -1 seconds to the -2, I find it here, and it represents units like that could only mean a quantity that is a pressure, right? So this must be pressure. And if we did the same thing for number 3, we would see that kilograms times meters to the -3 must be density. All right, moving on. Number 7. Well, 7 takes advantage of the fact that these units can be rearranged algebraically, and they ask you to simplify the SI unit expression and use the result to determine the quantity being expressed. Well, they give you AS over S, which is, as a unit, A stands for amps, S seconds over S seconds. And the idea here is that if we have seconds on the top and seconds on the bottom, the two can cancel out. I can cancel this seconds and that one, And that leaves me with just amps. If I look up what that represents, looking for the SI fundamental unit equivalent, if I go down and find amps, it represents an electrical current. And so on my paper I can say AS. If the units are in amperes, it must be electrical current. Excellent. Number 9. Drop down a page here. Nine says this. It says, how about if we take meters divided by seconds squared times units of seconds? What would that equal? And we can do this by saying, well, if I'm going to multiply a fraction and a non-fraction, I can create a fraction out of this second by doing this. Meters over seconds squared times, instead of just seconds, I'll put seconds over 1, just to hold the place there. Move it into the numerator. When I multiply fractions, I just multiply the numerators. Meters times seconds gives me meters times seconds. Seconds squared times 1 just gives me seconds squared. Now algebraically, I have a seconds on the top and 2 seconds on the bottom. So I can cancel this top seconds with one of these 2 seconds on the bottom. That is to say that this seconds would cancel out one of these 2. I would still have 1 second left on the bottom, which would give me meters over seconds, or as IB would write this without units in the denominator, meters times seconds to the -1 power. If I use my table, I can look up what that unit is equal to. Looking for SI fundamental units, I can scroll down to meters times seconds to the -1, and I can see that it corresponds with velocity. So this must be a velocity. All right. Moving on. Number 11. These problems get a little bit more challenging, or if not more challenging, at least more complicated. In number 11, they ask you to take units of N, which is newtons, divided by units of meters over seconds squared. Well, the trouble here is that newtons are not fundamental units. And so we can simplify this by taking newtons and moving it back into its fundamental units. And you'll see that'll give us some things that we can cancel out. So if I find SI unit symbol N for newtons, here, the symbol N represents newtons, but it is equal to, newtons are equal to kilograms times meters times seconds to the -2 power. And so I'm going to replace where it says N with that. I'm going to write, this is the same as saying kilograms times meters times seconds to the -2 divided by meters over seconds squared. All right. And if I want to write this as a fraction, I could say this is also equal to kilograms times meters. This seconds to the -2 just says it's going to be seconds squared in the denominator. Now I have a fraction divided by another fraction. Well, when we divide fractions, we multiply by the reciprocal. So I can change divided by meters over seconds squared to times, instead of meters over seconds squared, times seconds squared over meters. Oh, what would this give me? This would give me kilograms times meters times seconds squared in the numerator. And in the bottom, in the denominator, I would have seconds squared times meters. And I can cancel some things here. I can say this meters on top cancels with this one on the bottom. These 2 seconds on the top cancel with these 2 seconds on the bottom. And what I'm left with is just kilograms. Well, the kilogram, an SI kilogram is a unit of mass. And so we know that this quantity, if it's measured in kilograms, must be a mass. We're talking about mass there. Number 13. You know, I'm going to skip number 13 for the help. I think it's a great problem. 13 says watts times seconds. You'll need to figure out what a watt is equal to and rewrite this with whatever a watt is equal to times seconds. Once you've rewritten the whole thing in SI fundamental units, then you can go through and cancel some things. So I'll let you work on that. But I'd like to go through 15 with you. So I'm going to do that. One of the powerful aspects of looking at units this way is that every equation has to have units that balance on the left and the right in order to be a legitimate equation. So in number 15, they tell us that IB provides an equation that says that momentum is equal to mass times velocity. So I could say that momentum is equal to mass times velocity. And because of that, I know that whatever the units of momentum are, they have to equal the units of mass, that is kilograms. How did I find that? Well, if that's not automatic yet, it will be. But if I look up the quantity mass on my table, come down to where mass is, I can see that mass is bold. It's a fundamental unit. And we use M to represent it. It's measured in the SI unit. It's measured in kilograms, which has SI units of kg. So that's where I get this from. Times, so momentum has to have units that are equal to the units of mass, which is the kilogram, times the units of velocity, which if you look that up on the table, is the meter over the second, or the meter times the second to the -1. So what is this equal to? Well, we have kilograms times meters times seconds to the -1. Nothing can be canceled because all three of these are SI fundamental units. They can't be expanded into any other form. And so we have a kilogram meter per second. It asks you to add a line to the table on page 1 for the quantity momentum, which has an IB variable of P. And so if you do that, your table on on page 1, should have a quantity, a new quantity that is momentum. You can add it to the bottom of the table. The IB variable, it tells you, is a lowercase p. It should have SI units. Written out, we would call this kilogram meter per second. The SI unit symbol is just going to be kilogram meter per second. And the SI fundamental unit equivalent is going to be the same thing. So here I'm going to drop down one line, but the SI fundamental unit equivalent in the table is going to equal the same thing. It cannot be simplified anymore. Kilogram meter per second. Excellent. Good luck on the other problems.